Good morning. Here is our lesson for today on covalent compounds. Um, so let's go ahead and in your notes, you can call this Intro to Covalent Compounds and Covalent Bonds. All right, and today is 4/29. All right. So everything that we've been doing for the past, 3 or 4 weeks, has been showing ionic bonds, naming formulas with ionic bonds, naming ionic bonds, and so now we're switching. This is the other type of bond called a covalent bond or a covalent compound. So to compare and contrast the two, let's go ahead and we'll make a chart. We'll put ionic on one side and we'll put covalent on the other. So we have ionic and we have covalent. So I'm just going to continue this chart a little bit further. All right. So if you remember with ionics, when we showed the bond, we showed that ionic compounds transferred electrons. And we showed that transfer of electrons as something like this. Right? And we showed the transfer with this arrow. And how covalent compounds differ is they share their electrons. Let me do this in blue. All right. So when they share valence electrons, we're going to draw it either as a single, a double, or a triple bond between valence electrons. Here's the difference between the two. Transferring electrons looks like this. An example would be your friend asking to borrow a pencil. And you say, "Here, take my pencil." And your friend writes with your pencil for the entire class. So you have transferred ownership of your pencil over to your friend. How sharing would work is exactly as it seems. Your friend says, "Hey, can I borrow a pencil?" You're like, "Well, it's my only one. I need it too." And so you write some notes and then you hand the pencil to them and they write some notes and then they hand the pencil back to you and you write some more. So you're transferring the pencil back and forth so you both can use it. And that's what the covalent bond does. All right, so these guys are buddies and they're going to share that valence electron back and forth. So how are these made? When we did ionic bonds and we took, I don't know what it's not writing. We had an ionic bond. We took something from the left side and we paired it with something from the right side. So this is from the left side and this is from the right side. So this is between a, this is not working. So ionic bonds occur from something on the right and something from the left. So these occur between a metal and a non-metal. And they're held together by attraction of the ions. For covalent compounds, a covalent compound might be something like carbon dioxide or hydrochloric acid. So these are nonmetals bonding with a nonmetal. So we're going to take two things from the right side, two or more things from the right side, and bond them together. Okay, so this is from the right side of the table. Hydrogen is the exception. Hydrogen comes from the left side. And this is left side plus the right side. Okay, when we wrote and when we named ionic compounds, we used ions. We had plus or minus charges. We canceled. We crisscrossed. And in some cases, when needed, we used parentheses. And none of that happens with covalent compounds. So with covalent compounds, there are no charges. There's no cancel or crisscross. There's no parentheses. So how do we name or how do we write covalent compounds? We use prefixes and subscripts. There's no eights, there's no ites. Covalent compounds are only ides. And I think the easiest way to do this is just to kind of jump in to some examples. So I said that we use prefixes. There are 10 prefixes that we are going to use for covalent compounds. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So take a moment to copy those down. Prefixes 1 through 10. So here they are. These might be similar to some terms that you use in geometry or other math. So here we go. The prefix that means one, think about the ion that only had one type of atom, that's mono. Prefix for 2 is di. 3 is tri. 4 is like the old Nintendo game where each thing that fell down had 4 pieces falling. And that game is Tetris, and this is tetra. 5 is penta, like a pentagon. 6 is hexa, like a hexagon. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So those are our 10 prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And maybe even by the end of today's lesson, you will have all those memorized. So how does that work? Let's just go ahead and jump into an example or two. So keep those prefixes handy, and if you need to pause the video, if I'm going too fast, pause it to catch up. All right, so example 1. Let's say we have something like C2O4. Okay. C2O4. We use some prefixes. What's the prefix that means 2? Di. Di what? Dicarbon. What's the next prefix? 4 is tetra. And O is oxygen, but we wrote above here that the ending that we're going to use for covalent compounds is "ide." So we're going to change the endings of only the second element to "ide." So oxygen becomes oxide. Okay, so we use the subscript to determine the prefix. All right, let me give you guys another example. Example 2. Let's see, we have P3H8. Okay, P3H8. So we're going to use the prefix. All right, so 3, what prefix is 3? Tri. It's describing P, which is phosphorus. Okay, and then we go with the next one. 8 is octa. And here's where some endings are a little different. Hydrogen, a lot of people want to call it hydroxide. But if you remember, hydroxide was a polyatomic ion. There is no X in hydrogen. So there's no X when you name it. So hydrogen becomes hydride. All right. There's no X, so we're not going to call it hydroxide. So hydrogen becomes hydride. And really, that's the basics of it. So let's do one more example. Let's do N5P6. And some of these are not real compounds. I'm just making them up so you get a chance to practice naming them. All right, so the prefix for 5 is what? Penta. Penta nitrogen. All right, 6 is hexa. And change the ending. Phosphorus becomes, this is also an exception, phosphide. All right. So sometimes it helps if you kind of say the name quietly, like phosphoride is really nothing. Phosphide is this guy. All right. So that's our lesson for today. We'll do more naming later. I just wanted to give you guys the basics of it. And I wanted to go over the difference between covalence and ionics. So notice we didn't have to look at a chart. You're not going to use your polyatomic ion chart for this, okay? So take these notes and post them in your attendance tracker. Thank you.